Hello, and welcome to part 3 of my Navigating by App in the Wilds. This part is being re-recorded with new information about trails and trail difficulty. In terms of our navigation roadmap, we've arrived at step 3. That is, knowing where you want to go and the path that you want to take, which means trails or routes. So the first thing we want to know is, where do digitized trails in various apps come from? And the answer is they can come from a lot of different places. A very popular source is the OpenStreetMap Consortium. The source for the individual trail digitizations is unclear because in the OpenStreetMap Consortium, anyone can contribute and edit. Unless you dive into their system and look at the details, it's difficult to tell how those trails were collected. Nonetheless, OpenStreetMap trails tend to be amongst the most accurate publicly available digitized trails. In Forest Service regions in the United States, the U.S. Forest Service also maintains a database of digitized trails at a spacing of 10 meters. But these trails do not extend outside of the Forest Service, and as you'll see, they are not as accurate as the OpenStreetMap Consortium. In New Hampshire, we have the New Hampshire Granite, which is the New Hampshire State GIS database, which also has a listing of trails, but the vintage, quality, and spacing of these trails is extremely variable. And there are some apps, notably apps like All Trails or Hiking Project, etc., which can show you individual users' tracks, and they may use crowdsourcing to try and develop the average trail orientations and so on. And some databases probably even contain trails which have been digitized from old paper maps. And needless to say, these are less accurate than some of these other methods. Most apps, unfortunately, don't tell you the source of their data. For what it's worth, the Appalachian Mountain Club collects all its own data for their maps, and it's excellent in quality, but it's not available in any app at present. One thing you can be sure, regardless of the source, it is almost certainly collected by somebody walking a trail and collecting a GPS track in this day and age. And that means that the trails will have the same level of uncertainty as GPS data itself does. So here's a map of the Northern Presidential Range. Mount Madison is right here. The Madison Hut is down here where all these trails come together and so on. And I'm showing you trails, digitized trails from two different sources, the U.S. Forest Service in green and the OpenStreetMap Consortium in magenta. And as you can see, there are lots of places in this area where they don't exactly agree. And in some places, the disagreement is quite strong. So the question is, which of these digitized trails better reflects the actual trail on the ground? Because when we're trail finding in the dark or in adverse conditions, that's a very important question. Fortunately, we can address this question using LiDAR topographic data. This is an image zoomed into zoom level 17 of part of that area using LiDAR data processed with a technique known as texture shading, which applies a fractional Laplacian operator to the LiDAR data. And one of the advantages of this processing is that it enhances changes in curvature or surface curvature. And trails, because they are concave up in cross-section, show up very clearly as thin, dark lines. You can see clearly the airline trail and and the Valley Way Trail here, probably the most popular route up to the Northern Presidentials. And if you squint over here, you can even see a track for the Watson path. So these are showing us at a resolution of 1 meter where the trails actually are. Now, let me overlay the OpenStreetMap and Forest Service trails on the same image here. And I think you can see that OpenStreetMap in this case captures the actual trail orientations, although not perfectly, with much more fidelity than do the US Forest Service digitizations in green here. So in general, in the White Mountains, OpenStreetMap trails are more accurate than the US Forest Service trails. Uncertainties on average are 5 to 10 meters, but there are some trails which are off by more than 50 meters, as in the case of the US Forest Service digitization of the Valley Way here. And finally, just a reminder, if you zoom into higher magnification, that does not improve trail accuracy overall. All right, the other thing to know about digitized trails is that they're different from what you actually walk. Here's a simplified map of a trail that you might have actually walked here, but the digitization collects discrete points along the trail and then connects those with straight line segments to form a polygon, which approximates the trail, but is not exactly the same as the walk distance. Many digitized trails, including the Forest Service trails, are digitized at 10-meter spacings. And what this means is that the walk distance is longer, generally by a factor of about 2.5 to 3% than the actual digitized distance. So if you're wondering about the difference between the trail distances marked on signs or in the White Mountain Guide versus what your app is telling you, this is probably the reason shown here. All right. Now we're going to start on part 4 of our navigation roadmap. That is assessing trail difficulty. And to do that, I need to remind you first that maps are a projection onto a horizontal plane. Well, we walk up a ridge like this. On the map, it's in a horizontal plane like that. And the implication of this is the following. Here's a simplified cross-section with our hiker going up a slope. And the slope angle is the angle between the horizontal and the slope itself, as shown in this triangle. A common measure of slope is actually percent grade. And in the case of percent grade, it is the change in elevation, that is the vertical distance versus the map distance. And the slope angle here is if you take the tangent of the slope angle, it gives you the percent grade when multiplied times 100. Now, we've all seen signs like this on the highway, and you know when you do that your brakes are going to get a workout because for an automobile or in a truck, this is a seriously steep slope. But it's not really in real life. It's a 10% grade represents a slope angle of about 6 degrees. Now, to give us a more visceral feeling for slope angle and percent grade and the importance of these numbers for trail difficulty and safety, let's go to what's generally regarded as the steepest and most dangerous trail in all of the White Mountains, which is the Huntington Ravine Trail. And here I'm showing you an oblique view of Huntington Ravine constructed from the LiDAR topography for the area. And as before, we're going to do a flyover into the ravine and then up the head wall following the path of the trail. So we drop down into the ravine. You can see the actual trail can be seen on some of these LiDAR images, which have extraordinary detail in them. We go into the flat bottom of the ravine. There's the boulder field at the bottom. Then we turn and go up the fan and onto the steep ledges, up the steep part of the head wall, and over the top to the auto road. Now, if that didn't convince you that Huntington Ravine is a seriously steep trail, perhaps this picture, which I borrowed from the Terrifying 25 website, will convince you. These hikers are on the actual trail, as you can see by the arrow painted on the rock right there. And I think you would agree, this is a trail that you do not want to fall on. This is a trail profile from my White Mountain Hiker Northeast app. This is the topography along the trail itself. And you can see that between the two red dots on the trail profile, it has an average slope of greater than 35 degrees, or a percent grade of 71%. But the parts of the trail, such as this up here, are even steeper, 40 degrees. And even that isn't the true steepness of the slope, because the trail switches back and forth, reducing the overall grade, whereas the top of the head wall in a fall line is about 50 degrees. This brings up an important point about what's known as the angle of repose, which is defined as the angle at which loose material will slide or roll downhill on a dry slope. And that loose material could be our hiker who falls. Most trails in the White Mountains with slide in their name are at the angle of repose. For example, the North or South Triphammer Slide, the Flume Slide, and so on, are all at this range of values because those are loose blocks at the angle of repose. And any trail with a slope angle of greater than 20 degrees or 36% grade is a seriously steep trail and should be regarded with caution. Now, I borrowed some concepts from the ski industry to try and simplify how to think about assessing trail difficulty based on slope. And we're going to use the well-known ski symbols. And for a green circle, that is the easiest level with a slope angle between 0 and 10 degrees. Trails in this range are generally appropriate for all hikers. When we go up to 10 to 20 degree slope, this is our blue rectangle, blue square trail. This is a trail that requires sustained effort, but is not generally dangerous. Now, when we get to the Black Diamond trails at 20 to 30 degree slope, these are seriously steep slopes. And you should know that a fall on one of these slopes could cause significant injury. And finally, above 30 degrees, let's call these the double Black Diamond trails of the hiking world. These trails are terrifying to most of us. They are at or higher than the angle of repose, and that means that a fall on them, one of these trails, could be fatal. But remember, all trails can have dangerous sections to them. Your 0 to 10 degree trail can have a raging river that you could fall into and drown, or it could have a very short but very steep section that could be very dangerous to navigate if you were not careful. And also remember that it's easier and safer to ascend than to descend a steep slope. And finally, when you choose a hiking app, you want to choose one that will show you the slope so you can assess whether the trail will be difficult or not. Thanks. That's it for this section. Hope you learned something from this. And in the next section, we'll talk about pace and route planning.